Hello and welcome to the Mapei Academy Building Line webinar series. My name is Denis Gray. I'm the Mapei Australia Product Manager for Building Line Products. I'm glad to have you all on board today. Today's topic, as you would know, is resin flooring. This webinar will run for approximately 30 minutes, after which there'll be plenty of time to ask any questions that you may have. So for the moment, sit back, relax, and I hope you enjoy the presentation. Thank you for attending again. Okay. There's many different types of flooring requirements. There's many different industries, and in some of these industries, performance is more important than the aesthetics, but it's still also rather important to have a good-looking floor no matter what the application. In chemical industries, food and pharmaceutical areas, where performance is of primary importance, the resistance to harsh chemicals, the hygienic factor, and also safety are very critical, and appearance becomes a secondary requirement. In factories, warehouses, etc., it's more about mechanical resistance, but it's also performance that can be defined in a super flat floor scenario where no undulations can be permitted. Abrasion resistance and even slip resistance can be key criteria or factors required in this sort of floor. Hospitals, laboratories and clean room industries. Performance is defined by the hygienic requirements. Clean rooms can also require mechanical and chemical resistance, and also the aesthetics are quite valued characteristics. Floors should not harbour or emit any contaminants into the atmosphere, particularly in clean room, laboratory and hospital type applications. So it's important to ensure that the flooring system that's used is clean room certified. I'll talk about that a little later. In department stores and supermarkets and shop retail outlets, aesthetics and hygiene are the most important requirements. Mechanical and chemical resistance, slip resistance are also key factors for the safety of customers and also the employees. Undercover car parks, aircraft hangars and other industrial type buildings where performance is designed around vehicular traffic and rubber tired wheels, etc., being rolled across. And also where chemical resistance is very important, where oil drops and acid drops onto concrete can be a concern for the concrete if not protected. So why install a resin floor? The most important reasons are where dust is an issue. Dust can be a slip hazard, can be a contamination that gets into the air, or it can also foul or soil any production that's going on in those areas. Chemical resistance. Bear with me, sorry. Chemical resistance, where acids are dropped onto bare concrete. Concrete is not significantly resistant to acid spills. So protecting the concrete with a resin floor will extend its longevity. Liquid holdout, so oil stains or oil dropping onto the surface. A well-protected concrete floor will make the cleaning up of the oil or contaminants much easier, and will also stop it from absorbing into the substrate. Liquid holdout, also in the case of chemical resistance, liquids that are used in a production facility need to be held out from seeping into the concrete or through the joints and down into the subfloor or into the land below. And seamless flooring, where hygiene and cleanliness are of utmost importance. So in these sorts of areas where it doesn't harbour or allow any mould or mildew and contaminants to build up and grow. So seamless flooring is very important, particularly in food preparation areas or where complete hygiene is required. Slip resistance is another very important factor. And you see three different variances of slip resistant there on the left-hand side of the screen. It's very important to understand that slip resistance is completely controlled by the top coat or the seal coat over any aggregates that are used in that slip resistant system. And also that, as the next point comes up, ease of cleaning is also very important for a resin floor in a food type preparation or a highly clean environment. The higher the slip resistance, the more difficult it is for the floor to be cleaned. So it's a matter of finding a good compromise between slip resistance and ease of cleaning to provide the perfect floor scenario for the client. So if we talk about Mapei's resin flooring systems, firstly we start with the epoxy flooring products. The Mapei Coat I-24 is a chemical resistant coating. It's a roll coat or brush applied material, 100% solids epoxy with excellent chemical resistance properties. From there you move up to the Mapefloor I-302, which is a very versatile 100% solids epoxy resin material that can be used as a non-slip or a non-skid, a smooth, a high build system. So it can be an SL or a self-leveling floor, it can be a broadcast floor, or it can be a roll coat. So it has that versatility to be used in a number of areas. This product also has the clean room certification. Okay, so we start to talk about some of the systems in the Mapefloor I-302. The system 31 is a non-slip two-coat system. So that's the application of a primer and a top coat. The system 32 is a broadcast system, so it's also non-slip. So it's a prime coat and a base coat, broadcast, and then top coat to seal. The actual thickness of the floor has a direct relationship to, I guess, its robustness and ability to hold out chemicals and damage to the floor, still protecting the subfloor. The higher the thickness of the system, the better it can protect, and some surface damage still doesn't allow any chemicals or anything to get through the floor and to start to undermine that flooring system. We're a low thickness system, a thin roll coat, if mechanically damaged, can provide access for chemicals to get straight through into the subfloor, and apart from deteriorating the concrete, can rapidly reduce the life expectancy of the coating. So we look at system 31 and 32, non-slip two-coat systems, non-slip three-coat systems. From there, we move to the system 33, which is a true self-leveling floor system. So this is also two coats, but a primer and then a thick built up or bulked out resin system, troweled onto the floor, spike rolled and left to dry. We move from the to the polyurethane cements, CPUs, from the epoxy resins. And in this range, we have the Mapefloor CPU NZ, which is quite unique, and I'll talk a little bit more about this further on. It's a single component non-skid system. We also have the Mapefloor CPU MF, which is a two-coat system, smooth or non-skid applications and self-leveling. And the ancillary products, which are the colorants. So which system where? Let's move through from the most or the least demanding to the highest demanding applications, so you can see the pecking order of the flooring systems to ensure that the right floor is installed for the right purposes. We look at Mapei Coat I-24. As I said before, it's 100% solids epoxy resin, high chemical resistance. It's a two-component epoxy paint. There's no primer required, so you apply it in 2 or more roll coats. It can be applied in a non-slip, so if that's the criteria, a non-slip floor, and you are using Mapei Coat I-24, the first coat should be applied and the second coat broadcast and a seal coat over the top. Otherwise, broadcasting into the first coat can provide some compromise to the chemical resistance due to the thin layer on the top sealing over the aggregates. It comes in a 5 kilo pigmented container or in a 15 kilo unpigmented, where various coloured Mapei colour pastes are applied. The ideal area for I-24 is for storage bunds, acid and oil areas, in workshop, motor workshop areas, plant rooms, etc. Any area where a cost-effective but highly robust and chemical resistant coating is required. The Mapei Coat I-24 has some wonderful attributes that will satisfy that. So we step up from the I-24 to the Mapefloor I-302 system. This has phenomenal versatility. So as I said before, it can be a smooth or a non-slip appearance, has higher durability that comes with the higher thickness. The I-302 SL System 31 is compromised, so it comprises of 2 coats, non-slip pigmented epoxy broadcast between 0.8 and 1.2 millimeter thickness generally. The first coat is a pigmented epoxy primer SN, and it also has then broadcast 0.5 sand mixed in to add some volume to the mix, and then surface broadcast. The second coat is the Mapefloor I-302 in the same colour to complete the floor system, and that's a self-leveling 0.8 to 1.2 millimeter thick coating. So into the unpigmented epoxy goes a pigment paste, so the Mapei colour paste, the 15 kilo I-24 and the 20 kilo Mapefloor I-302 SL require 2 pigment packs to be installed or to be added in mixing, and it comes in this range of standard colours. This system is ideal for shops and stores, showrooms, offices, storage and food preparation areas, and generally a lighter duty type application because it's not considerably thick in its coating thickness. We step up from there to the System 32, which is a much higher thickness and a higher durability, non-slip finish. And then from there, we also go to System 33, which is a much higher thickness, high durability, smooth, attractive finish. So you have the option of a slip resistant or a smooth, self-leveling floor system from this product. So the I-302 SL System 32, it's a 3-coat, non-slip, pigmented, high-thickness epoxy broadcast system, generally 3 to 3.5 or 4 mil in finished thickness. The first coat, non-pigmented epoxy, so primer SN is applied with a 0.5 broadcast sand mixed in and then broadcast over the surface as well. Second coat is the I-302 SL with the 0.5 sand mixed in and then also surface broadcast. And the third coat is the Mapefloor I-302 with no other additions but pigmented, and that seals the aggregate and the slip component of the floor system. So this system is ideal for undercover car parks, storage, clean rooms, food processing areas and shops. The I-302 System 33, as you can see from the picture there, is a very smooth, self-leveling, attractive floor. So it has very little slip resistance in a wet area, but for areas where ease of cleaning and high aesthetics are required, this is the perfect choice. So a 2-coat, smooth, attractive, pigmented, high-thickness epoxy self-leveling system. generally 2 to 3 millimetre thick. It's a self-leveling material, and it can take any minor substrate defects out also. But defects should be attended to before the floor goes down to ensure that the smoothest of floors can be finished. So when we're looking at this I302SL System 33, the first coat is a non-pigmented primer with 0.5 sand mixed in and then surface broadcast. The second coat is a pigmented Mapefloor I302 with a much finer filling sand mixed into the resin and then flooded onto the surface, troweled across the floor and spike rolled to provide a very smooth, even and gloss finish. So when would we step up from an epoxy resin floor to a cement polyurethane system? So a choice that can be made once you understand the attributes of the different products. When there's aggressive cleaning, any thermal shock issues where steam cleaning is required or it goes from cold to hot very quickly, the Mapefloor CPU cement polyurethane systems are certainly the answer. They will withstand thermal shock considerably better than an epoxy resin system. They have the highest wear resistance, so where forklift traffic and lots of robust abrasive requirements are needed, then the CPU system is certainly beneficial. For the highest impact resistance, the dropping of metal meat hooks and the like in an abattoir or any preparation areas, the cement polyurethane system offers extremely good impact resistance compared to the more brittle epoxy, which can tend to shatter when enough force is exerted on point load. So also for the highest chemical resistance, the cement polyurethane systems also offer extremely good chemical resistance. So where there's abrasion requirements, where chemical resistance is a requirement, and where you have impact and maybe thermal shock, the cement polyurethane system is by far the best choice. Interestingly, if the substrate is damp, the Mapefloor CPU system can be applied to a surface saturated dry substrate. This is something that an epoxy resin cannot be applied to. You must wait until the substrate is down to a reasonable moisture content, generally speaking around 4%. So the CPU product consists of a 3-component, part A polyurethane, part B polyurethane, and a part C cement aggregate blend. But you must be careful that this can't be applied as a 3-component system. It must have the colour also added to it. The Mapefloor Mapicolor CPU is required in the Mapefloor CPU NZ and MF. It's a powder form pigment, but it also contains active ingredients that are essential part of the actual mix. So to not apply the pigment would not give you the complete system or the complete floor product as indicated on the data sheet. To show you now a video of the mixing. The A and the B component are different colours to ensure when mixed that no streaking is seen. You know when it's mixed properly. Part C is then added, and the pigment and the other active ingredient, which is a 5 kilo pack. So what we're looking at here is the Mapefloor CPU NZ being mixed. So onto the Mapefloor CPU NZ, it's a 3-component non-slip cement polyurethane 1-coat system. So this system only requires one application. The substrate needs to be obviously prepared, but it can be damp, can have moisture in it. It's imperative that every CPU, cement polyurethane floor, has the anchoring grooves, and I'll explain those a little bit further in the slides ahead. But the anchoring grooves, and then the Mapefloor CPU NZ is applied as a single coat between 4 and 6 millimeters across the floor. So this system is in and out the same day. There's no waiting for primers to dry and moving on to the next step and the next step. It's preparation of the floor and installation of the floor in one step. So there's no primer required. The anchoring grooves are required. It's very important that these are used. The trowel finish is the application method, and it provides a non-slip finish, providing the application is poured out onto the floor and troweled quickly into place and then left. The more you work the material or try to manipulate it around, you can start to lose some of that slip resistance, but the slip resistance is built into the material, even up to the 6 mil thickness, and provides an excellent opportunity to get in and out, finish a floor in a commercial kitchen or in a abattoir or a butcher shop, anything like that, all in the one day. This is just showing the anchoring grooves that are required. So when we talk about the anchoring grooves, they actually pin the cement polyurethane down to prevent any shrinkage or lifting up from the edges. It's an important criteria required by all cement polyurethane materials. The idea is to cut into the substrate twice the width and the depth of the actual coating that's being applied. And the positioning at the perimeter of the floor. So in a room as shown here, a cut is applied 50 to 100 mil in from the boundary of from the wall. There's also anchoring grooves around any penetrations or columns. And also around any drains. And of course where you terminate the floor at the end, or when flooring is finished for the day and it's going to come back later on to do more of the floor, then an anchor groove is also applied at that point when the work stops. So this is an important part of the cement polyurethane system, the anchoring of the material onto the floor, around the perimeter and through all of the penetrations as seen in the slides previously. So when we look at the Mapefloor CPU MF, it's a 3-component self-leveling smooth cementitious polyurethane. It's a 2-coat system, and it can be a damp substrate again. The anchoring grooves are imperative. This one, the actual Mapefloor CPU MF, can be used or is used as a scratch coat primer. So thinly applied, troweled across the surface as a primer layer, and then the CPU MF is applied over the top of that as a self-leveling floor, spike rolled, as it shows in the slides ahead. So the standard system has a smooth finish, but it can also have a non-slip finish. So broadcasting into the Mapefloor CPU MF, a second coat can also occur, and in that case then a top coat is required to seal it off. So applying a thin scratch coat to seal the substrate and to prevent any pinholes. You can use as a first coat, if the substrate is dry and the area isn't subject to thermal shock, you can use primer SN and surface broadcast with sand as an alternative to a scratch coat of the Mapefloor CPU MF. The second coat is a flood of the surface with the Mapefloor CPU MF, as is typical with a self-leveling floor. A trowel is a good way to gauge the thickness, and then back roll with a spike roller to release any air bubbles. So in summary, we've talked about dust-free, wear-resistant factor, the chemical resistance. We talked about liquid holdout, seamless flooring, talked about slip resistance and the ease of cleaning and where they come together. Two courses slip resistance will provide a very difficult surface to clean, and too smooth will obviously be easy to clean but can be a slip hazard. So finding the right compromise is very important. So when the floor will be subject to thermal shock, aggressive cleaning, the substrate is damp, or when the highest performance is required, in all cases go for a Mapefloor CPU system. Typical installations are in food or beverage manufacturing, butcher shops, meatworks, commercial kitchens, or everywhere that wet cleaning processes are used. The CPU is a very beneficial partner in coating floors. So the CPU NZ is a single component trowel applied non-slip CPU, and the CPU MF is a two-coat self-leveling smooth CPU. And as I said earlier, the MF can also be made slip resistant by broadcasting of aggregates. In summary, the I-24 is a versatile, easy to use, highly chemical resistant epoxy paint coating. There's no primer required. It's easy roller application, so the skill set is not too high. It can be broadcast for slip resistance. Comes in a 5 kilo pigmented light grey or dusty grey, or in a 15 kilo unpigmented that pigment pastes are applied to. It's a thin coating system. The high durability you step up to a much thicker system like the I-302. So the I-302 system, again, this one is a two-component epoxy, 100% solids, can be applied in 3 different systems, the System 31, System 32, and the System 33. 31 is the most economical non-slip system for less demanding applications. 1 coat of pigmented primer SN broadcast, and a 2nd coat, sealer coat with the Mapefloor I-302 SL as a top coat. There is also a System 34, which I haven't mentioned, but that is also for less demanding applications, where 2 coats of I-302 is applied much in the same fashion as the I-24 directly onto the prepared concrete without a primer. System 32 is much thicker again, so this is a non-slip system broadcast. First coat is a non-pigmented primer SN with 0.5 sand mixed in, then the surface broadcast. Second coat is pigmented I-302 with 0.5 sand mixed in again, and then also surface broadcast. So it builds the thickness of the floor up. And the third coat is the seal coat over the aggregates to seal the floor and finish. System 33, it's the thick self-leveling smooth finish. First coat is non-pigmented primer SN. The second coat is the I-302 with the 0.5 fine filling sand installed into the mix, and it's flooded onto the floor, troweled out and spike rolled to a smooth finish. So this brings us to the point where the resources that we have regarding these systems. There's a systems for resin and cementitious floors brochure that's available. We have a whole range of technical data sheets for each of the individual products. We also have work method statements, and any other additional resources are also downloadable from our website. So this brings us to the end of our webinar on resin flooring today. I hope you've enjoyed it. I'd appreciate if you'd like to stay online and ask any questions. I'd be more than happy to answer those. Alternatively, you'll also see on the last slide here is my name and email address and also mobile phone number. So if anybody would like to contact me after the webinar, or if any of your colleagues that haven't seen today's webinar would like to view it in the days ahead, it will also be uploaded onto our website where you can see the whole range of Mapei Academy webinars from building line, resilient, and ceramic. So thanks again. I'm glad you enjoy. I hope you enjoyed today, and I'm glad you attended. If you have any questions, I'm more than happy to answer them now. But if not, have a good afternoon, and thanks for attending. So if anybody has any questions, by all means, please type them in, or you can use the conventional methods, as I said, to email me or to phone me. Not right now, but but afterwards. I'm just waiting to see if any questions come in. Bear with me, I'll have a look at the. Okay, I can see one here from Dave Baggs. Systems are useful as clear coats over polished concrete. This is quite a complex issue and quite a complex one. It depends very much on what the requirement of the floor is, whether there's going to be vehicular traffic or whether there's going to be a pedestrian traffic and the like. But generally speaking, we have our Mapei Coat 58W, I58W finish, which is a clear, low sheen material. In the gloss side of things, we're still yet to introduce that, but I'll be more than happy to understand a little bit more about what the requirement of the floor is, and I'll be able to answer a little bit better on that one. Okay. Bear with me a moment, I'm just trying to find the question here. Okay, there's also another question, what do I mean by broadcast? That's a very good question. What I mean by broadcast is the casting of sand, an aggregate filler, generally a 0.5 millimeter quartz sand, into the wet surface of the epoxy. So what it does is it creates a coarse sandpaper type finish in readiness for the subsequent coat, but also sits down into the wet resin and provides some bulk to it and increases the actual thickness of the system. I hope that answers that one. Here's another question here. How many degrees is the maximum service temperature for I-24? Another great question, thank you. Epoxy resins tend to have a very low heat or thermal resistance. Epoxies have a glass transition temperature, or where they start to soften, generally around the 50-degree mark. So in water or in constant temperatures above 40 or 50 degrees, epoxy resins tend to be less suitable for those type of applications. But again, to be able to understand exactly in what application we're talking, I'd be more than happy to discuss that one further. But definitely, the maximum service temperature for epoxy resins generally runs out at about 50 degrees maximum. Once you go over that, you start to run into the what they call the glass transition temperature of the epoxy, where it starts to soften and lose its characteristics. There's another question here. It says, are the epoxies rated to go over the Mapei level up range? Yes, they are. Generally, the criteria for an epoxy floor or for a cement polyurethane as well is about a 25 MPa structural floor. So providing the floor leveler is structural, well applied, well bonded to the substrate, and an epoxy floor can be applied over the top of that, or even a screed. Certainly in the case of putting a CPU over a leveler, becomes a much more complicated and complex situation, and we'd need to do that. We'll understand those on a case-by-case basis. So hopefully that answers that question. Again, if any of these, if you'd like more clarification, by all means, email me. Just looking through here at the other questions. The clear coat reference was for domestic flooring, no specific needs. It's referring to a previous question. Again, be more than happy to have a chat to you about the actual application and where we can assist. Someone's asked the question, is the clear Mapei Coat finish I-58W a matte or semi-matte finish? Yes, it is. Another question here is in reference to broadcasting, is it always to refusal? For a slip-resistant floor and to ensure an even aesthetics and not patchy, then yes, broadcasting to excess is the ideal scenario. If it is in the case of a broadcast of the primer coat for a key, it doesn't necessarily have to be, depending on the requirements or the mechanical loads on the floor. The more broadcast the primer coat is, then the more accepting it is to carry higher loads. So there is a direct relationship there, but no, not necessarily. It doesn't always have to be broadcast to excess, but it's important in the finish coat where you're sealing that last broadcast. The excess scenario is the best because it'll give you an even finish. Somebody said, so if the atmospheric temperature is in the low 40s and the floor is in the sun, this could be an issue for epoxy floors. It would be a very big issue for epoxy floors. Epoxy floors would discolor quite significantly in an exposed application. So direct sunlight will discolor the epoxy, and eventually it's more of an aesthetic thing in the early stages, but will eventually start to make the surface of the epoxy quite chalky. So initially it's more aesthetic, but over time it can become more of a life expectancy scenario. Somebody's asked a question, very good question. Actually, I'm glad this has been brought up. It said here that from my experience with the industry, most installers as utilising a two-coat system without any aggregate in the prime coat. Do we recommend the I302 as a two-coat roll coat system? And the answer is yes, we do. The broadcast is best practice. In a case of a light duty or a medium duty type floor where there's not extreme abrasion requirements and loads, then the broadcasting of the prime coat is not a necessary component. So you can apply either the I302 as 2 straight coats, or you can apply the primer SN and then the I302 over the top of it without broadcasting if you want a smooth roll coat system. Okay, let's see. Here's another question here. Do we have a system that can resist sulfuric acid at 98% at 160 degrees? Not in our current range, but there is a system that is available that we don't carry in Australia at the moment. But I'll be more than happy if you contact me to discuss that and see if there's anything we can help you with there. Okay, that looks like it brings us to the end. I hope I have answered all those questions. I have a bit of a technical difficulty here in that the window that I have to see the questions is a very narrow band, and I'm not quite sure why that's the case. But any other questions, by all means, please email me or give me a call. My number and my email address are on the screen there. Again, thank you so much for your attendance today. I hope I have answered those questions well for you. And if there's other clarification required, by all means, please give me a call. Okay, that brings us to the end. Again, thank you so much. I appreciate your attendance, and I look forward to having you on the next webinar. Thank you again.